Welcome friends, welcome you all in my channel Chemistry of Molecules. I am Tanmay. So today I shall explain an important topic, that is haloform reaction, means the conversion of an ketomethyl group. This ketomethyl group into, or you can say this secondary alcohol with having a CH2H, this unit will be converted into corresponding carboxylic acid, and a reagent, that is CHX3 is haloform, and this X should be chloride, bromide, iodide. I have never mentioned here fluoride. Why? Because it is not possible to form this fluoroform directly using this method. I will explain why. So first we will explain this, and secondly we will explain some exception about haloform reactions after explaining the mechanism. And please keep it in mind that this is a selective method for carboxylic acid preparation. If I am saying, because you can see after this it produces a carboxylic acid. Okay, so please keep it in mind, this is a selective method for preparation of this carbonyl group to carboxylic acid, or this secondary alcohol into carboxylic acid. And actually this overall factor is mainly dependent on a basic concept, that is alpha halogenation of ketone under basic condition. So in this context I want to call you up again that previously I have also explained in my videos that alpha hydrohalogenation of ketone under acidic or basic condition. So if you didn't see that, I suggest you please go through it. So let's explain. First of all, this reaction is a conversion of ketomethyl to this. But I am saying an exceptional thing, that is conversion of the secondary alcohol. What happens? This secondary alcohol is converted into corresponding this ketone in presence of halogen. How? Halogen acts as an oxidizing agent. So this OH first reacts with, for example, if we take iodide, so attacks here, it comes out. Okay. So to produce this CHO, this proton will be eliminated and it will be produced this. So this is H, this is CH3. And another thing, under basic condition, this halogen, it is not expected that halogen will be stable. What will happen? This X2 plus HO minus means it will attack, for if we write properly in this way, so it will leave and it will produce X minus plus HOX, and here X is delta positive and oxygen is delta negative. So since X is delta positive, so in this reaction procedure it becomes a electrophile. So it became an electrophile. That's why this nucleophilic attack on this halogen possible. So it is better, instead of writing this, it is better that you write this. Okay. So in this way this is produced, and after that base will abstract this proton, it will come here and it will leave. So ultimate product is this ketone, means ketomethyl compound. So that's how this alcohol works. And in this context I want to mention that this haloform reaction is one of the detection tests for ethanol who have such unit. And in this way, more specifically if I say, that is iodoform reaction, and that is a detection test of ethanol, because this iodoform produces a yellow crystal of CHI3, which is heavier due to the heavy molecular weight of this iodide and yellow crystal, so it is very easy to detect it. Okay, so let's explain everything. First, let's explain the mechanism. As I told, this carbonyl will attack this hypohalite, sorry, this X. So here, and it goes, so in this first of all, I made a mistake. First of all, the reaction proceeds through halogenation of ketone under basic condition. In presence of base, it produces enolate. First step, I have explained this enolate formation in detail, so I am not going to explain this enolate. And after that, this enolate reacts with this OX. So in this way. Okay, so sorry. So this X and these enolates reacts through carbon. Okay, why? Because generally this OX bond is not that much stable, but compared to this carbon X bond, carbon halogen bond is more stable. So O and CH2X, and since actually the reaction is based on the acidity of this hydrogen, actually reaction starts by abstraction of this alkali, abstraction of this proton by this alkali, so acidity of this hydrogen matters. So after monohalogenation, acidity increases, so reaction don't stop here, reaction continues and ultimately produces this trihalogenation. Okay, so right now these halogens are electron withdrawing, so this carbon is electron deficient. As a result, it withdraws electron density here, and we know that carbonyl group also withdraws electron density. Consequently, this carbon became so much electron deficient that nucleophilic attack by hydroxyl is possible, and what happened? It comes out and it produces RCOOH and CX3. Now question minus, how it stabilizes? Because delocalization of this negative charge over the vacant d orbital of this X. So first of all d orbital, second of all another point is minus I effect of this X. So in this way this carbon is stabilized, this negative charge is stabilized. Another thing, right now it's a carboxylic acidic proton and this is a carbon ion. So this abstract this proton to finally produce this carboxylate anion plus HCX3. This is haloform. Okay, so this is the main base mechanism of this haloform reaction. So you can observe here that the initial stage is enolization, and this enolization is the RD state, means rate determining state. Enolization is rate determining state. Although the halogen is involved in the haloform reaction, but it is observed that the rate is not that much dependent on this amount of halogen, because the RD state is the enol function. Okay. So let's give let's say something about fluoride. So we have observed that preparation of HOX is important for the reaction, but instead of that, if we consider this as a fluoride, then this hydrofluorous HOF is very unstable and explosive liquid, so it is very difficult to prepare. Second, reaction of fluorine with water produces ozone, oxygen. So in this way are different other products also. So it's much reactive, so reaction doesn't happen. But how to prepare fluoroform? If you want to really prepare fluoroform, then the reaction is iodoform plus silver iodide. It produces that CHF3, means fluoroform and silver iodide, because silver iodide precipitates out, but silver fluoride is soluble. This is soluble in water, but this is insoluble. So in this way, this fluoroform could be prepared. Traditionally, it is not possible to prepare. Okay. So we have explained the mechanistic part. Let's discuss about a trick. For example, let's given you that ketone 1 equivalent, and for example, instead of halogen given bromide 1 equivalent. So 1 equiv. So what will be the product in presence of alkali? Means under haloform reaction condition. So you must keep if you understand the reaction mechanism properly, I guess you can answer this question. How? Because we know that one molecule of this ketone needs 3 molecules of halide. How? Because one halogen, this X2X, will be attached to this, and another will leave as an anion. So for 3 mole needed. So for 1 bromine, 1/3 mole of this haloform will be produced. Haloform, or we specifically, since it is bromine, it should be bromoform, HCBr3. So 1/3 mole bromoform. So similarly 1/3 mole of carboxylic acid will be produced. Okay, fine. So whatever the left, so through 2/3 mole of this ketone will be left in the reaction medium. So keep this factor in mind, it will be helpful for you. Okay, so we have just explained about the haloform reaction in haloform reaction. Okay, so right now we have already understood that Ketomethyl group is essential. Okay, and another thing, it could be converted to this acid. Okay, in this context I am to give another example. What an example? See, this ketone. This ketone could be obtained in pinacol rearrangement, and this ketone could be converted in presence of this, for example, bromine alkali to the corresponding carboxylic acid. So this is a very good way to prepare this tertiary butyl containing carboxylic acid. Okay, but instead of that, if we take this ketone, so this is an aromatic ketone with this trimethyl substituted. Its common name, this backbone unit name is mesitylene. How it could be prepared? Reaction between mesitylene and acetyl chloride, field cut acylation. So if we do the same reaction, for example, bromine and alkali, will it produce haloform? No, it will not produce haloform. What will produce? It will produce this tribromo. Okay, CBr3, this is methyl, this. Why? Because bromination happens on this position via enolization. So it's true, enolate formation, it's true, it will happen. But attacking here, you need to attack this, need to attack here. And another thing, it is true that these two bulky methyl bulkiness of these two methyl group and the pi cloud will not attack this nucleophile to go and attack this carbonyl carbo. So in this way, reaction will stop here. Okay, so it is also important to know whatever the other factors. So for example, such question could be given to you in the exam, and if you don't understand the basic factor, then you will be confused and there is a chance of mistake. Second point, we have always told that CH3 needed. Is there any possibility that in absence of CH3 could be done? Okay, it could be done. For example, let's see this. Okay, this is the derivative. For example, some other separation, substitution R1, R2. So if we do this haloform reaction, what will happen? This first will be halogenation of ketone under basic condition. So these two hydrogen will be replaced by halogen. So what it will produce? It will produce this dihalo carbonyl derivative. So now you can see it's a cyclic compound. Due to the withdrawing effect of these two chloride, this carbonyl center became very much electron deficient. And another thing you should keep it in mind, this is an active methylene group, means here abstraction of this proton is more easier compared to the parent Ketomethyl group. So this reaction will happen very smoothly. For example, if we consider this, if we take chlorine and alkali, or better it says that, for example, sodium hypohalite, okay, in place of base. So this is chlorine is plus oxidation state. So this, and right now alkali will attack here. So what happened? Alkali will attack here, and after that it will come back and open up this ring. Okay, so what will happen? So write everything as it is. It will reduce the chance of mistake. So this O and CCl2 minus. This negative charge is stabilized by the conjugation of this carbonyl and minus I, as well as d orbital conjugation of these two chloride atom. So what happened? This produced, and right now see this looks like an intermediate of the haloform reaction. What do I say? For example, you can consider this CCl2 minus is an intermediate produced after dihalogenation. So another halogenation possible, and actually this happens. What happened? These attacks to this hypohalite, and in this way this trihalogenation occurs, and after trihalogenation, when this trihalogenation is complete, this alkali further attacks here, and ultimately chloroform and another final product is produced. So this is OH. Actually, after workup, this OH and this dicarboxylic acid plus chloroform is produced. Okay, so these are some unique examples related to haloform reaction. Now, in every case, we are observing this, that reaction is happening in water, and under this condition it produces this. So is it possible to carry out this haloform reaction in absence of water? Actually it is possible. So for that I will give you one example. For example, we can have this monobromo ketone very easily, because halogenation of ketone under acidic condition produces this monobromo derivative. So reaction of monobromo derivative with pyridine produces a cationic center. Means, so this is the pyridine. Okay. So this is, and what happened, this pyridine lone pair attacks this, and we know the SN2 reaction on this alpha halo ketone is very facile. I have made a video, please look at that, it will be very easier understanding for you because of the conjugation of sigma star and pi star. In this way this reaction becomes very much facile. So what happened, this is produced. So this reaction next, in presence of water free, means for example alkali in ethanol. Okay, like ethanolic KOH. So what produces this attacks here. Okay, so ultimately what is the consequence? It is goes and backs, and this produces these ROOH plus and ylide, because this negative charge comes out. This ylide CH2 minus. Here you can see the positive charge and negative charge remain closer together. That's why this is stable. Second of all, this can have a resonance stabilization. This, and in this way this. So in this way this ylide is stabilized. So this, and after that this ylide abstract this acidic proton to produce ultimately RCOOH. This is another method to produce the carboxylic acid, similar like haloform reaction. So keep it in mind, this question could be given to you such, and I believe that you should not make a mistake. And finally, the last example I want to give is about the asymmetry. The asymmetry. So you can see after haloform reaction, if this R contains a asymmetric unit, okay, what will be the condition? So in this center asymmetry will not be hampered. But here if we say, for example, actually not alpha halogenation of ketone, for this is this, so CHR1R2, and this is asymmetric center, and after that this halogenation happens, so no asymmetry will be maintained. Why? Because it undergoes through a enol formation, and in this way it's sp2 hydrogen with planar. So equal side has a probability for the attack of this negative charge to this electrophilic center, for example halogen. So in this way this enolization, this asymmetry is destroyed. So keep this factor also in mind. So this is the end of this haloform reaction discussion. So in this reaction we have produced this haloform, which is a very important reagent for many other applications. For example, one is Reimer-Tiemann reaction. Okay, Reimer-Tiemann reaction, I will explain in next video about this Reimer-Tiemann reaction. And second of all, this haloform is utilized to prepare fluoroform and other derivatives, which are very important reagent for this cooling. For example, fridge, air conditioner, those things, and they are less environmentally pollutant, or this less environmentally harmful compared to the freons, which destroys the ozone layer. But these fluoroforms are a very strong greenhouse gas. So this is the end. So if you like my teaching, please give a like, subscribe my channel Chemistry the Mystery of Molecule, and please share this video among your friends such that many people could be benefited, and please press the bell icon to get the notification of every new single video I upload. So see you in my